Hello everyone, and today we're going to start learning how to graph parabolas. So again, standard form for a parabola looks like standard form for an equation, y equals ax squared plus bx plus c. Okay, now to start graphing a parabola, the first thing we need to do is find the vertex. And to find the vertex, we use the x-coordinate of the vertex actually, because we have to do this in two stages in standard form, is we are going to first find the x-coordinate by doing the negative b, so that's this guy right here, opposite sign of that guy, all over 2 times the a value. Then from there, after you get the x vertex, you then plug that back into the equation and solve it out, and that gives you the y-coordinate of the vertex. So for example, here we have y equals 3x squared. Now first off, I need this equation to look like this. So the problem is, it doesn't look like that. So I have to fill in the pieces. So I know I can use plus 0x, and again the reason why it's 0x is because 0 times x is just 0, and we don't make it show up because frankly there's no point. And then we do plus 0 for the c value. Okay. So first things first, let's find the x-coordinate of the vertex. We do negative b, so we're going to take this guy. So negative 0 all over 2a, or 2 times 3, which is 0 over 6, which is just 0. Okay, so this is the x-coordinate of my vertex. So when I do an ordered pair, because we're doing a coordinate, my x-vertex is going to be 0. Now, to find the y-vertex, we plug this 0 back into the equation. So again, y is going to equal 3 times 0 squared. And again, first thing according to order of operations, we do 0 squared, which is just 0. And 3 times 0 is 0. So my vertex in this instance is the coordinate 0, 0. And we'll talk about what that means in a little bit. Alright, let's look at another one. Now first off again, I don't have all 3 pieces for standard form. I only have 2. So notice I'm missing the x. So I'm going to replace that. X squared plus 0x minus 4. Okay, so first thing I need to do is let's find the x-coordinate of the vertex. So we're going to do negative b, so again negative 0 all over 2a. Now remember there's a 1 hiding here, folks, so it's 2 times 1. So it's 0 over 2, which is just 0. So my x-coordinate of the vertex is 0. Now let's go back and get the y-coordinate of the vertex. So I'm just going to fill back into the original equation. So 0 squared minus 4. And again, 0 squared is 0. So 0 minus 4 is negative 4. So that's my y-coordinate of the vertex. So my vertex location is 0, negative 4. Alright, now here we have all 3 pieces. So let's take a look at this. So I don't have to fill in any zeros. So let's start. Negative b. So I'm going to do negative negative 4, which as we all know is positive 4 now. All over. Now the a value is 1, so 2 times 1. So 4 all over 2, because 2 times 1 is 2. And 4 over 2 is just 2. So my x-coordinate of the vertex is 2. Now let's go back and get the y-coordinate. Okay, so we're going to put 2 in for the x's. So 2 squared minus 4 times 2. Plus 8. Again, 2 squared is 4. 2 times 4 is 8. Plus 8. And when I add that all together, negative 4 minus 8 is negative 4. And negative 4 plus 8 is positive 4. So my vertex is 2, 4. I'll let you try this one on your own. I want you to find the vertex for me given this formula. Okay, so given this thing right here, I want you to calculate it and I'll give you about a minute or so. So again, leave the tape running and work the problem, and in about a minute I'll come back and we'll do this up. Alright, I'm back, folks. So here we go. First thing we do, let's get our x vertex, negative b. So that's negative 8 all over 2 times a, which is 1. So negative 8 over 2 is negative 4. So my x-coordinate of the vertex is negative 4. Now let's put in the y value. So negative 4 squared plus 8 times negative 4 plus 10. Okay. Well, negative 4 squared is 16. 8 times negative 4 is negative 32 plus 10. 16 minus 32, that's negative 16, plus 10 is going to give us a grand total of negative 6. So, my vertex location is negative 4, negative 6. Alright, now, the other way we're going to see parabolas written is something called vertex form. Now, vertex form looks a lot like this, but it's going to be a lot easier for us to find the vertex because the vertex coordinates are here and here. If we notice, the opposite sign of h with whatever k is makes up our vertex. So it makes life a lot easier. Alright, so here you go. You're asked to find the vertex. So since this is vertex form, I'm going to just be looking at these two pieces to find the vertex. Now, for the x-coordinate, we do the opposite sign of h. So this is negative 4 that's in here, which means when it comes out, it's going to go in, whoops, went too far. It's going to go in as positive 4. The k value, which is the y-coordinate of the vertex, just goes in as it is. So since it's positive 5 here, it's positive 5 here. And there's your vertex. Pretty easy. Alright, let's look at another one. So again, vertex form is showing. You're asked to find the vertex. So again, I'm going to take the opposite sign of this guy. So that's negative 2. And I'm just going to take whatever this is. So that's negative 3. And there's your vertex. Pretty easy. Alright, now this one's a little trickier. But again, nothing too crazy. Okay, so again, we're going to look at these two pieces. So again, opposite sign of this first piece, so that's 1. And then just take whatever this is, negative 1. And there's your vertex. Alright, now this one has a little trick, because notice, we're missing the k value. So again, since we're adding, it's going to be plus 0. Okay, so no big deal there. So now, here we go. Take the opposite sign of this guy, so negative 1. And with whatever that is, so that's going to be just 0. And there's your vertex. Pretty easy. Alright, now, we do have some definitions that you're going to need to know when we're doing this. Now, some of these terms we've already gone over before when we did the absolute value equations. So like the axis symmetry acts like our mirror. But the new feature is we need to know the equation of the vertex, or the axis symmetry, sorry. And to do that, it's always going to be x equals, and then whatever the x-coordinate of the vertex is. So let's say, for instance, you're asked to find the axis of symmetry, and you're given the vertex coordinate of, say, negative 2, 4. Then your axis symmetry is x equals, and whatever this is. So that's negative 2. Okay, we're going to be doing a lot of that. with this section. A shift, again, just like the absolute value equations, okay, tells us where we moved away from 0, 0. So again, if we have our graph, and my vertex is up here, let's say it's at the coordinate 3, 2, okay, now a shift just basically explains where this vertex went. So again, in this instance, because we went right 3 and up 2, right 3 up 2 would be our shift 2. Okay, so we would explain the shift was to the right 3 and up 2. Reflection is used when describing the direction that the graph is going when compared to the parent function. Now typically with a parabola it's y equals x squared. So if you're to graph y equals x squared, the graph goes up like so. So again, when the graph is going up, when our graph, when compared to this guy, is going upwards, we say it's none because it's going in the same direction. When the graph goes down, we say it's reflected over the x-axis, just like we did when we did the absolute value graphs. Okay. New feature with a parabola that we haven't seen before is whether the graph opens up or down. Okay? If the graph opens up, then it's making a U shape. Okay? If the graph opens down, it's an upside down U. So U is up. So U is going up, so U for up, and an upside down U, so it'll probably look like that. That's when it's going down. Alright, the next piece of definition we're going to need to know is minimum or maximum. Okay? Now this deals with the vertex itself. Again, if the vertex is the lowest point in our graph, then the vertex represents a minimum value, or the smallest value you're going to have. If the vertex is the highest point in the graph, then it is a maximum. So for instance, if my parabola looks like this, now the vertex is the point where, our graph changes directions. Okay? So if our vertex is, say, here, there we go, okay, then this obviously right here, based on what I'm seeing with all these other values as I go up this way and I go up this way, this is going to represent the smallest values. So therefore, this is going to be a minimum. Okay? Whereas if the graph looks like this, okay, then my vertex is here, then this vertex represents the maximum value because, again, after that point, all my values start going down. So therefore, this would be a max. Okay? Now, the maximum value is the minimum or maximum value is the y-coordinate of the vertex. So say I had a vertex of, say, 3, 4, and my parabola is going up. Okay, so my graph will do this, and this point right here, the vertex, is the coordinate 3, 4. So we would say that the minimum this would be a minimum first of all, because again, it is the lowest point on my graph, and then the value would be the y-coordinate of the vertex. So I'm going to say y equals, and then grab this guy, and say y is 4. And there is your minimum value. Now again, maximum works the same way. So yeah, let me clear this out. Okay. So again, so if I wanted to do a maximum, okay, so my graph would be going down. Okay, so it'll look like this. And say the vertex is 3, 4 again. Okay. So again, this coordinate right here, 3, 4. Now again, because this vertex is going to be the highest point I have, we're going to say it's a maximum. And then for the value, again, we say y equals, and then grab the y coordinate, and it's going to be 4. Okay? Now, shrink, stretch, or neither. Now this pertains to the a value. Now again, remember, the a value is in standard form, that's the number in front of the x squared. And the a value in vertex form is the number in front of the parentheses. Okay? So we're going to be looking at this. So here, let me write it out so we can see it. So y equals ax squared plus bx plus c plus, okay, that's standard form. In vertex, y equals a x minus h squared plus k. Now again, shrink, stretch, or neither deals with this value right there, depending on which equation you are given. Okay? Now what we're going to do is we're going to take the absolute value of that number, whatever that is, and we're going to compare it to the number 1. Okay? Now if the value is less than 1, which means we're going to be dealing with a fraction, okay, then that means it's a vertical shrink. Okay? If it's greater than 1, which means it's bigger than 1, obviously, so it would be a stretch. And if a is 1, then it is neither. So for instance, if I had, let's replace this one with, let's say a negative 2. So say I had something like that. Okay? So what I would do is we are going to take the absolute value of negative 2. Now since the absolute value of negative 2 is positive 2, and then we compare it to 1. Well, 2 is greater than 1, therefore this is going to be a stretch. Okay? Now domain. Let's deal with all the possible x values that the function can have with no restrictions. Okay, if there are no restrictions, we say there's all real numbers. Now again, a restriction is going to be where the graph doesn't go. However, in most standard parabolas, you're going to find, no matter what the parabola looks like, okay, there's hardly ever going to be a restriction on the x's. The x's, remember, go from left to right. And there's no gaps or holes in my graph. Therefore, typically, the domain will be all real numbers. Okay? Now, the range, however, that's where it gets a little dicey. Okay, so here's my axes again. Let's say I put this, our parabola, through the coordinate 0, negative 2. I'll make that my vertex. Now let's do 1, negative 2 based on how this came out. Okay, so this is going to be the coordinate 1, negative 2. Now notice, in an example like this, my graph never goes below negative 2, hypothetically, of course, based on what I'm seeing. Okay, so since my graph does not go down here, it stays all above negative 2. So like we saw in the absolute value graphs, we're going to say our range values, y, are going to be greater than or equal to negative 2. Okay, because we can be at negative 2, we're going to be above negative 2, we just never go below negative 2. Alright, so here we go, now the fun part, how to graph a function. Sorry, I was thirsty. So first, find the vertex. Now again, depending on your given formula, you're either going to do the standard, which is the negative b over 2a, and then plug in, or if you're given vertex form, you just pluck it out of the equation. Okay. Then we're going to plot our axis of symmetry. Again, that from our absolute value section. Remember, that's going to be a dotted line through the vertex. Okay. Now, then our next step, it gets a little fun, is what we're going to do is we're going to take our a value and times it by 1, 3, 5, and 7. Now what this is going to do for us is it's going to tell us how this parabola moves. Now, automatically you're going to move right all the time. So it's going to be right 1, right 1, right 1, right 1. Oops, right 1. Forgot to write it in. Okay. Now what we're going to do is this is the multiplication of 1, 3, 5, 7 tells us that we're going to go up or down 1 3, 5, 7 times whatever our a value is. Okay. Now again, this may sound confusing, but it's going to be easier to see when I show you. Okay, so just bear with me, follow along, and I'll show you what I'm talking about. Okay, and then we're going to plot our points from step 2, and then reflect those over the axis of symmetry, just like we did with an absolute value graph. Okay, so here it is. We're going to graph this thing. So step 1 said we are going to first identify the vertex. Now, because my vertex isn't, my equation, is in standard form, we got to do x vertex, which is negative b all over 2a. Okay, so here's my b value, and 1 is my a value. So this is going to equal negative 4, which is positive 4, all over 2 times 1. Whoops. 2 times 1. Or you can get 4 over 2, which is just plain old 2. So the x-coordinate of the vertex is at 2. Then, to get the y-coordinate, okay, we're now going to plug that back in to my original equation. So y vertex equals to, we're going to do 2 squared minus 4 times 2 plus 4. Okay, well, 2 squared is 4. Negative 4 times 2 is negative 8 plus 4. Add this up, so 4 minus 8 is negative 4, and then plus 4, so we get a vertex, y vertex of 0. So there's your vertex, negative 2, 0. So what we're going to do is let's scroll in to 2 zeros, not negative 2, 0, positive 2, 0, and let's make our point. 2, 0 is right there, so we make our point. So there's your vertex. Change the width on my pen a little bit here. There we go. So there's your vertex. Now, then we also have to graph my axis of symmetry. Okay, so that is a dotted line through this coordinate. Try to make a nice straight line if you can. Okay, that's our mirror line right there. Now, now we have to figure out how this thing actually moves. Okay, so what we're going to do is we are now going to use our 1, 3, 5, 7. Whoops. 2. Oh, great. 2, 0. Okay, so what we're going to do is we're going to take our a value. Let me change my pen size again. That was awful. So let's change. We're going to do a times 1, 3, 5, and 7. So again, what this tells us, again, we're going to go right 1 every single time. Okay. Now, what we're going to learn in the second part when we multiply these things is how this thing actually moves. Now, based on what we're seeing, the a value, which is right here, is 1. So, we're going to scroll back. Okay, let's go back to here. And we are going to change the a value to 1, because that's what our a is. So 1 times 1 is 1. 1 times 3 is 3. 1 times 5 is 5. 1 times 7 is 7. Which means, since it's positive 1, positive 3, positive 5, positive 7, some of you probably already guessed that we're going to go up 1, up 3, up 5, and up 7. Now again, will you be able to plot all those points? Probably not. But again, we'll do our best. Okay? So here we go. So knowing that, we're going to come back to our graph. Okay. Let me grab this. Maybe not. Okay, so sorry about that. Now I'm drawing all over the place here. There we go. All right, so here we go. We're going to go right 1, up 1. So from our vertex, we're going to go right 1, up 1, make our point. Then we're going to go right 1, up 3. So right 1, up 3. 1, 2, 3. Then we are going to go right 1, up 5. Right 1, up 5. 1, 2, 3, 4, 5. So right there. Okay, so that's half the parabola. So what we're going to do is we are now going to reflect those over the axis of symmetry. Okay, so I'm going to start with this one. So I'm going to go reflect 1. Okay. Okay, we go 1, 2. So 1, 2. Okay. This one we go 1, 2, 3. So 1, 2, 3. So right there. Oops. Use the wrong color. Not that it really matters, but I like to be consistent. So now, then we connect the dots. Alright, so there's our parabola. Now, let's answer the rest of these questions underneath here. Okay, so let's put this back kind of the way it was. Okay, now, axis of symmetry, remember that's the x coordinate of the vertex. So x equals, since that's 2, this is 2. Okay, the shift. Shift tells us where this thing went from the origin. Now notice, the origin is at 0, 0. I went to 2, 0. That means I went to the right 2 spaces. Reflection, okay, if the graph is going up or down. Now the graph in this case goes upwards, which means there is no reflection, so none. Alright, this graph opens upwards because it makes a U. So open up. Now, minimum or maximum, okay? Now, is my vertex the lowest or the highest point on my graph? Well, based on what I'm seeing here, there's my vertex. That is the lowest point on my graph, which means this is a minimum. The minimum value, y equals, and the coordinate of the y coordinate of the vertex tells us our value. So y is 0. Shrink, stretch, or neither. Okay, this dealt with the absolute value of a. Absolute value of 1 compared to 1. Well, the absolute value of 1 is 1, so that is equals. So since it's equals here, then it's none. Now for kind of the tough part. Domains. Are there any restrictions on my x's? Now, since notice how this is going to go forever and ever on my x's, this is going to go forever and ever with the positive x's, there really is no restriction. Therefore, we're going to use funky r, all real numbers. However, my range values, notice my vertex, my values stop at 0 for my y's. I never go into the negative area here. Therefore, we're going to say our y values will always be greater than or equal to 0. And we're done. Okay, don't panic yet. I know I can hear some of you freaking out. We'll do another one so you can get it. Alright folks, let's take a look at this next problem. Now again, first thing I notice is that my equation is in standard form. Okay, so the first thing I need to do is find the vertex. So again, to find the vertex, x vertex is the formula negative b all over 2a. Okay? So again, here's my b value. It's going to be the 8. My a value is the 2. So the vertex is going to equal negative b, so negative 8, all over 2 times 2. Okay. So negative 8 and 2 times 2 is 4. Negative 8 over 4 is negative 2. So my vertex x-coordinate is negative 2. Now, then we got to get the y-coordinate. Okay, so y value. Now we're going to put negative 2 back into our function. So 2 times negative 2 squared plus 8 times negative 2 plus 3. Okay. So I square this. So 2 times 4. 8 times negative 2 is negative 16 plus 3. Okay. Now I'm going to multiply this. That's going to be 8 minus 16. 16 plus 3. 8 minus 16 is negative 8 plus 3, or negative 5. So the y-coordinate of the vertex is negative 5. Okay? So there is my vertex. So let's move in. We're going to graph the coordinate negative 2, negative 5. Alright? So negative 2, negative 5 is right here. Okay. Now, next thing we can work on is our axis of symmetry. Remember, that's going to be x equals, and it's the x-coordinate of the vertex, so negative 2. So we're going to draw a dotted line through this coordinate, because that is our axis of symmetry. That is our mirror line. Alright. Now, then we have more work to do, because now we've got to figure out how this thing moves. Okay. So let me clear out some of this work that we did for the vertex. Actually, I got room down here. Okay. So remember, we're going to take our a value and times it by 1, 3, 5, and 7. Okay. Now what this is going to tell us is, again, we're going to go right 1, right 1, right 1, 1, right 1. But the a value is going to tell us what we're going to multiply with and tell us if we're going to go up or down. Now in this case, my a value is 2. So I'm going to replace that. My a value is 2, so 2 times this. So 2 times 1 is positive 2. So that means we're going to go up. 2 times 3 is positive 6. 2 times 5, positive 10. 2 times 7 is positive 14. Okay, so that says we're going to go right 1 up 2, right 1 up 6, right 1 up 10, as far as we can go. Alright, so let's move back in. Okay, so from our vertex, right 1 up 2, 1, 2. So right there. Okay, then we're going to go right 1 up 6. 1, 2, 3, 4, 5, 6. Right 1 up 10. But we're going to go off our scale, okay, so we can't go any further. So now we're going to reflect these over the axis of symmetry. So again, one space, so one space right there. Okay. 1, 2, so 1, 2, so right there. All right, now we connect the dots. And there's your graph. But remember, we have all this other stuff over here we got to fill in now. Okay? So here we go. Drop this down a little bit more. There we go. Perfect. Alright, so here we go. Let's fill in the information. Shift. Now again, we went from the origin to negative 2, negative 5. So that says we went, oops, let me turn my pen on. That would help. Pen. So we went left 2, then we went down 5. Okay. Reflection. Now again, reflection, okay, tells us when we're comparing to the parent function. Now again, notice how the graph is going upwards. Okay. So if the graph goes up, it's none. So our reflection in this case is none. Now it opens up because it makes a U. Now again, minimum or maximum, we look at where the vertex is. Is the vertex the smallest or the largest point on our graph? And that is going to be the lowest point, so it is a minimum. Our minimum value, again, is the y-coordinate of the vertex. So y equals -5. Shrink, stretch, or neither. Okay, so we do the absolute value of the a, which is 2, and compare it to 1. Well, the absolute value of 2 is 2. Now, 2 is greater than 1, so this is a stretch. Now, my domains, are there any restrictions or stoppages when the x? The answer is no, so that is funky R. Now, the range, notice that my graph does not go below -5. That's an awful dotted line, but again, notice my graph doesn't go any lower than -5. So that means all my y values are going to be greater than or equal to -5. And there it is. All right, let's look at the next one. All right, folks, here's our next problem. So again, notice we are in standard form. Okay, so I get the vertex, x vertex equals -b all over 2a. Here's my b, and notice my -1 will be my a. So -b is -6 all over 2 times -1. So -6 over -2, which will be +3. Okay, so the x-coordinate of the vertex is -3. All right. Now, let's go find the y-coordinate of the vertex. So again, we just plug that back in for x. So -1 times 3 squared plus 6 times 3 minus 2. So -1 times 9. 6 times 3 is 18 minus 2. Okay. Multiply this, -9 plus 18 minus 2. Okay, put that together, we get 9 minus 2, which is 7. All right. So my vertex is 3, 7. Okay. So let's scroll in here, and let's plot our coordinate, 3, 7. Okay. So I'm going to change my pen a little bit here so I can make a nice dot. All right, so let's go to 3, 7 over 3, up 7. So right there. Beautiful. All right, now we have to figure out how the line moves. Okay. So let me scroll back down a little bit here. Hey. There we go. Just give myself some room to work. All right, now again, we're going to take our a value, times it by, oops, didn't mean to do that. We do by 1, 3, 5, 7. Okay, so we go right 1, right 1, right 1, right 1. Now again, my a value this time is going to be -1. So 1 times -1, I got to scooch back, give myself a little more room. So when I do this, -1 times 1 is -1, which means we're going to go down 1. -1 times 3 is -3, so down 3. -1 times 5 is -5, so down 5. -1 times 7 is -7, so down 7. Okay, so this is how my line moves, my parabola moves. All right, so here we go. Let's scroll back in. Again. All right. So we went to the right 1, down 1. So right 1, down 1. Right 1, down 3. 1, 2, 3. Up. Right 1, down 5. 1, 2, 3, 4, 5. Right 1, down 7. 1, 2, 3, 4, 5, 6, 7. Now, what did I forget to do way in the beginning? Right, I forgot my axis of symmetry. I'm sure most of you guys were screaming at me, hey, gee, what about the axis of symmetry? Yeah, you're right. I didn't do that. So let's do that. That's an awful axis of symmetry. Let me try that again. That was awful. Alright, let's try this again. what happens when you have too much coffee in the morning. You're just a little shaky. That's a little better. Alright, so now we are going to reflect these over the axis of symmetry. So one space, so one space. Okay. One space. Okay. Next one. 1, 2. So 1, 2. Okay. Okay. Next one. 1, 2, 3. So 1, 2, 3. Okay. Next one is over 5. 1, 2, 3, 4. Or it's over 4, sorry. 1, 2, 3, 4. There it is. Now let's connect our dots. Oh, hey. What game you playing back there, Bella? No answer from the gallery. Okay. Alright, so there's our parabola. Now notice this is a little different than what we've seen thus far, so let's go through and see what we did. Alright, axis of symmetry. Remember, that is the x-coordinate of the vertex. Okay, so, whoops, forgot to turn on my pen. X equals, and again my x-coordinate is 3, so x equals 3. The shift. Now we have to describe where this thing went from the origin. Now since we went to the coordinate 3, 7 for our origin, we went to the right 3, up 7. That looks awful. Let me fix that. Okay. Up 7. Okay. Reflection. Now notice this time, my graph does not go up or down. It does go up or down. It goes down in this case. Now notice we say with reflection, anytime it goes down, we say over x-axis. That looks awful. Try that again. Too much coffee this morning. Over x-axis. Okay. Now, does this graph open up or down? Now, because the U is upside down, we're going to say it opens downwards. Okay. Minimum or maximum value. Now, again, this goes to the vertex. Now, notice this time, my vertex is the highest coordinate on my graph. Because notice all my y values after the vertex, and even before the vertex, are well below it. So therefore, this is a maximum value because the vertex is the highest point I get. Now, the coordinate, the maximum value, again, is the y-coordinate of my vertex. So y equals 7. Now, shrink, stretch, or neither. Now again, remember, we take the absolute value of the a and compare it to 1. Now again, my a value is -1. Okay. Now the absolute value of -1 is 1. So 1 is equal to 1. And since it is equal, we're going to say none. Okay. Now, for the domains, again, there are no restrictions on my x's. There's no holes or gaps in my graph. So this is funky R. Now, for the y values, again, notice if I make a line through here, my graph never goes above y equals 7. All my coordinates are below that. So therefore, y will be less than or equal to 7. And there we go. Okay? Alright, so I'm going to let you try this one on your own. Let's see how you do. I'll give you about a minute or two, and then we'll come back and talk about this one. I'll give you about 2 minutes. So give this one a try. Let's see how you do. How we doing, folks? Hopefully we're doing okay. I'm going to give you about another couple of seconds, about 10 or 15 seconds to give this a try. I didn't forget about you. Okay, I'm still here. But again, this takes a while, so I'm giving you a little extra time to work on it. So, hopefully everything's going good. Alright. Alright, so I want to get started. So again, if you're still working, just keep working or pause the video. Okay, but I'm going to get this started because there's a lot of work to do here. Alright, so first thing I notice, my equation is in standard form, which means to find the vertex, x vertex, negative b, all over 2a. Okay, so again, here's my b, here's my a, so here we go. Vertex equals negative b, so negative 8 all over 2 times negative 4. Alright, so negative 8 all over negative 8 is 1. So my x-coordinate of the vertex is 1. Alright, now let's go to the y-coordinate of the vertex, so we're going to put 1 back in. So negative 4 times 1 squared plus 8 times 1 plus 3. Okay, so 1 squared is 1 plus 8 plus 3. So negative 4 plus 8 plus 3 is 4 plus 3, which is 7. So my y-coordinate is 7. So there's my vertex. Okay, so let's go to 1, 7, and we shall make our graph, our vertex coordinate. So 1, 7. There it is. Now again, let's not forget this time. We got to draw on the axis of symmetry. I won't forget it this time. So again, it's a straight up and down line through the vertex. Alright. Now that we have that, we have to do our work for our movement to see how this graph moves. So again, it is a times 1, 3, 5, 7. So right 1, right 1, right 1, right 1. Okay. So now, here we go. We're going to take our a value, which in this case is going to be the negative 4. So negative 4 times these pieces. Negative 4 times 1 is negative 4, so we're going to go down 4. Negative 4 times 3 is negative 12. Negative 4 times 5 is negative 20, so down 20. And that's going to be down 28. Oops, D. Now, so let's see what we can do. I think we're only going to be able to plot one of these points, but let's find out. Okay, so we're going to go, here we are. Okay, so here we go. Let's go. We're going to go right 1, down 4. 1, 2, 3, 4. Right 1, down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right there. And we're not going to be able to do any more than that. So now, let's reflect this. So 1 space, so 1 space. Okay. 2 space, 1, 2, so 1, 2. Boom. Alright, now let's connect our dots. Alright. Again, should be more on the dots. I didn't. Alright. So there's our parabola. Now, let's take a look. We got to fill in all this fun information down here. Alright, so now let's do the axis of symmetry. Okay. So again, is the x-coordinate of the vertex. Hey, where are you going? Where's this thing going? Now, let's try this again. Okay. So again, it's the x-coordinate. So x equals 1. Shift, where did the vertex go from the origin? It went up 1, right 7. Reflection, again, because the U is upside down, it's over X axis. Okay, make that an I. Okay, does this open up or down? Again, because it's making an upside down U, it is down. My vertex is the highest point on my graph, therefore it is a max. The max value, again, is the y coordinate. Y equals 7. Okay. Shrink, stretch, or neither. Again, we look at the a value. Absolute value of a when compared to 1. Well, in this case, the absolute value of -4 compared to 1. Absolute value of 4 is +4. Now, since 4 is greater than 1, that means it is a stretch. Okay. Now, domain. There's no restrictions or holes in my graph for the x's, so funky R. Range. Now, again, my y values, as we noticed, do not go above 7 again. So, therefore, y is not equal to, I'm sorry. Let's get rid of that. Not equal to, because then we'd have a straight line. Y is less than or equal to 7. And there it is. Alright, I'll give you about a minute or two to try this one on your own, a little bit simpler. And I'll come back, and so just leave the tape running. I will come back and we'll talk about this one. Okay, so good luck. Alrighty, folks, got another couple of seconds to do this up. Again, then I'll come back and we'll talk about it. Okay. Alright, so I'm going to get this thing started. If you're still not done, just pause the video. Okay. Alright, so here we go. First thing we need to do, we need to find the vertex. And again, because this is standard form.
Daddy, can I sit next to you?
Yeah. Come on up. Okay. So here we go. -b, b, and 1 is the a. Alright, so -b, +2, all over 2 times 1. Okay. So 2 over 2, which is just 1. So the vertex x is 1. Now, for the y coordinate of the vertex, again, we're going to go to 1, or put 1 in for x. So 1 squared minus 2 times 1 plus 3. 1 minus 2 plus 3. 1 minus 2 is -1 plus 3, which is 2. So my vertex is 1, 2. Alright, so let's scroll in. Let's plot the coordinate 1, 2. Okay, so over 1, up 2. Right there. Marvelous. Now again, let's not forget, like I did earlier, the axis of symmetry. Alrighty. Now, let's from here we got to figure out how this thing's gonna move. So again, a times 1, 3, 5, 7. Right 1, right 1, right 1, right 1. Okay. Now my A value in this case is going to be positive 1. So 1 times 1 is up 1. 1 times 3 is 3, so up 3. Up 5. Up 7. Alright, so that's our movement. Okay. So here we go. Okay, right 1, up 1. Right 1, up 3. Right 1, up 5. 1, 2, 3, 4. Okay, now we'll reflect these over the axis of symmetry. 1, so 1. Okay. 1, 2, so 1, 2. Alright, so now let's draw our parabola in. Like so. Okay, so there's our parabola. Now let's fill in all this information. Oops, A. Okay. There you go. Axis symmetry is the x coordinate of the vertex. So that's hey. Sorry. So x equals 1. Shift. We went to the right 1, up 2. Reflection. Since the graph makes a U, there is none. Does it open up or down? Because it makes a nice U, it opens up. Minimum, maximum value. Again, looking at my vertex, that's the lowest point I have, so it is a minimum. The minimum value is the y coordinate of the vertex, so y is equal to 2. Shrink, stretch, or none, so the absolute value of A compared to 1. So A is 1 in this case. The absolute value is 1, so since that's equal, that is none. Now, domains. Now, since there's no gaps or restrictions on my domain, there is funky R. And again, my y values, again, notice my graph does not go below 2. Therefore, y has to be greater than or equal to 2. And there it is. Alright, now this one's going to be tricky, so I want to work this one with you. Here, let me give myself some room to work.
Like me?
Yeah, like you. Alright, so here we go. Now we got to worry about this value, but again, it won't be that bad. So, standard form, x vertex, negative b, all over 2a. So, negative 2, all over 2 times a half. Well, that's easy. Negative 2 times over. Now 2 times a half is 1. My x is negative 2. Okay. Now let's put that into the function for our y. So 1/2 times negative 2 squared plus 2 times negative 2 plus 3. So 1/2 times 4 minus 4 plus 3. Now, multiply this. So 4 times a half is 2 minus 4 plus 3. Negative 2 plus 3 is equal to 1. Okay, so let's plot our graph. Okay. So here we go. Let's plot the coordinate negative 2, 1. So back 2, up 1. Our axis of symmetry. Like so. Alright, so here we go, folks. Now we got to do... Hey, what are you doing? Alright, now we got to figure the movement on this thing. Okay, so here we go. A times 1 3, 5, 7. Right 1, right 1, right 1, right 1. Now again, because this is a half, this is going to be a little trickier. Because a is 1/2 this time, and again, we can't clear the fraction. I've got to give myself a little bit more room to work here. Alright, so here we go. 1/2 times 1 is positive 1/2, so we're going to go up a half. We're going to go 1 times a half is up 3 halves, or technically we're going up 1 1/2. Okay. 1/2 times 5 is up 5 halves, which is up 2 1/2. And 1/2 times 7 is up 7 halves, which is up 3 1/2. Okay, a little bit tricky, but we'll do okay. Alright, so I'm going to zoom in real close to get the fractions in. Alright, here we go. And where did my graph go? There it is. Alright, so here we go. Right 1 up a half. Okay. Pen. So right about there-ish. Right 1 up 1 1/2 from this level. So 1 1/2 would be right there. Right 1 up 2 1/2. 1 2 1/2. I'm doing a couple dots here. Right 1 up 3 1/2. 1 2 3 1/2. Okay, so right there. So there's my graph, or my spots. Now let's reflect that. I don't know why I just zoomed out. Hey, stop it. Alright, so here we go. So, 1 space, so right about there. Okay. 1 2, so 1 2. Okay. 1 2 3, 1 2 3. So right there. Okay. 1 2 3 4, 1 2 3 4. Alright, and then connect your dots. Wow. Alright, so there's our parabola. Now let's fill in all this information and see what we got. Okay. So here we go. Axis of symmetry. X equals -2. Shift. We went left 2, up 1. Reflection, because the graph goes up, it is none. And as we just said, it opens up. Minimum or maximum, again, my vertex is the smallest point on the graph, so it is a minimum. My minimum value is the y-coordinate, so y equals 1. Now, shrink, stretch, or neither, the absolute value of a compared to 1. So the absolute value of a half compared to 1, or 1/2 is compared to 1, which is less than. So this is a shrink. Okay, domains, there's no restrictions, so funky R. Now my range again, my y values do not go below 1, so y's are going to be greater than or equal to 1. Alright, and there's that one. What happened, honey?
I don't know.
Okay. Alright, so here's this next one. Let's give this one a shot, and then we'll see what we can do. So I'll let you work on it. Alright, folks. Alright, so here we go, folks. Let's take a look at this problem. So again, standard form. Got the b value, I've got the a. So x vertex negative b all over 2a. Alright, so I'm going to go 8 all over 2 times negative 2. 8 over negative 4. 4. Which means that's going to be negative 2 for my x vertex.
Wait, can they hear you through that?
Alright, so now let's go get the y vertex. Okay, so we're going to fill the negative 2 back in. So negative 2 times negative 2 squared minus 8 times negative 2 plus 1. So I square this first. Alright, so negative 2 with 4. So we plus 16 plus 1. Negative 2 times 4 is negative 8. Plus 16 plus 1 is 8 plus 1, which is 9. Alright, so we have our vertex. So now, let's zoom in, and we'll plot our vertex. Okay. Alright, so we are going to go to the coordinate negative 2, 9. Oops, gotta fix my... Shoot. Let me fix that first. There we go. Alright, so here we go. Negative 2, 9. Alright, about... Now let me make that better. Okay, close. Alright, now, let's figure out our axis of symmetry. Okay. So that's going to be a vertical line right through here. Okay. Alright, now we got to figure out how this thing moves. So again, that's going to be our A times 1, 3, 5, and 7. So right 1, right 1, right 1, right 1. Now my A value in this case is going to be negative 2. So negative 2 times 1 is negative 2, so we're going to go down 2, down 6, down 10, down 14. Okay? Alright, so let's graph those up. Okay. Alrighty. So right 1, down 2, 1, 2. Right 1, down 6. 1, 2, 3, 4, 5, 6. Right 1, down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now we reflect those over the axis of symmetry. So one space, 1, 2, so 1, 2. Okay. 1, 2, 3, so 1, 2, 3. Alright, and then we'll connect our dots.
That's pretty slick stuff you got there, Pete.
Yeah, it is. Alright. So now, let's fill out the rest of the stuff so we can figure out what we're doing. Okay, axis symmetry, so that's the x coordinate of the vertex. So x equals negative 2. Shift, we went left 2, up 9. Reflection is over x-axis. Goes down. Okay, because the vertex. Alright, so minimum, maximum. The vertex here is at the top of my graph, so it is a maximum value. The value, again, is the y coordinate of the vertex, so y equals 9. Now shrink, stretch, or neither. Remember, we look at the absolute value of a, comparing it to 1. Absolute value of negative 2 compared to 1. Absolute value of negative 2 is 2 compared to 1. And 2, when compared to 1, is greater than. So since it is greater, it is a stretch. Now looking at my graph, there's no restriction on my x's, so that is funky R, or all real numbers. And the range, now notice again, my graph does not, my y's do not go above 9. So therefore my y's are all going to be less than or equal to 9. Alright, now here's something's changed. Obviously our form has changed, which is going to make our lives a heck of a lot easier. Alright, so here we go. Vertex form. So what I'm going to do for my vertex is get the opposite of this guy, negative 3, to whatever this is, 4. So there's your vertex. No work, no muss, no fuss. It's already there for you. Alright, so let's plot that. Okay, so let's go to negative 3, 4. Right there. Alright, now let's plot our axis of symmetry still. We still do that. Okay, now we are still, in order to graph this thing, whoops, we're still going to do the 1, 3, 5, and 7. That doesn't change. So A, whoops. So A times 1, 3. Actually, I'm going to do it down here. I have more room. A times 1, 3, 5, 7. So right 1, right 1, right 1, right 1. Now my A value in this case is, again, remember, in front of the parentheses. So in this case, it's 1, since I couldn't see it. So now here we go, multiply. So 1 times 1 is positive 1, so up 1, up 3, up 5, up 7. Okay. Alright, so let's graph this up to the best of our ability. Okay. So here we go. Right 1, up 1. Right 1, up 3. Right 1, up 5 is going to go off the graph. Okay, so we can't do that. So now let's reflect. So 1 space, so 1 space. Do a better job. Okay. 1, 2, so 1, 2. Alright, so now let's draw our line, our parabola. Oops. There's the vertex a smidge. Something like that. Alright, now, we still have all this other stuff we got to fill out, though, but again, not much has really changed. Okay? So, here we go. Axis of symmetry. X equals negative 3. Shift. We went left 3, up 4. Reflection. Since the graph is going up, there is none. The graph opens up. Minimum or maximum, again, my vertex is the lowest point of the graph, so it's a minimum. Minimum value, again, y equals 4. Shrink, stretch, or none, again, we compare the A, so absolute value of A compared to 1. Absolute value of 1 compared to 1. And the absolute value of 1 is 1, so when I compared it is equals, therefore it is none. Okay, domain. There's no restrictions, so funky R are all real numbers. The range, now again, my y's, notice, on my graph, do not fall below 4. So y has to be greater than or equal to 4. Alright, let's look at this next one. Now again, vertex form. First thing I'm going to do is take the opposite of that guy and compare to this. Alrighty, so now let's graph that up. So we're going to graph the coordinate 1, 4. Okay, so 4, boom, right there. Okay, let's draw on our axis of symmetry. Okay, now let's figure out how this thing moves. Alright, so A times 1, 3, 5, 7. So right 1, right 1, right 1, right 1. Now my A value in this case,
Hey, do you know what you're doing?
Alright, so my A value is -2, so -2 times that. So again, we're going to go down 2, down 6, down 10, down 14. Because again, my result, because -2 times 1 is -2, which indicates we go down. Alright, so here we go. Alrighty, so right 1 down 2. Right 1 down 6. 1, 2, 3, 4, 5, 6. Right 1 down 10, but we're going to go off the graph. Alright, so now let's do our reflection. So 1 space, 1 space. One, 2, so 1, 2. Alright, now let's graph this thing up. And again, you should go through all your points. It's kind of hard to do when you can't see what you're doing. Alright, so here we go. Now let's fill in the rest of this fun stuff. Oh, A. Back. Alright, so here we go. Axis symmetry. X equals 1. Now, shift. We went right 1, up 4. Reflection, since we're going downwards, so down. X. Axis. Minimum or maximum. Again, my vertex is the highest coordinate on my graph, so it's a maximum. Maximum value is the y coordinate of the vertex, so y equals 4. Now shrink, stretch, or neither, we compare the absolute value of A to 1. Whoops. Not equal to yet. Compare to 1. Okay. And the absolute value of my A is -2 this time. So that goes 2 compared to 1 is greater than, so it is a stretch. Domain is the funky R because I have no restrictions. And again, notice my y values this time do not go above 4, so y has to be less than or equal to 4. Alright, I'll work this one with you one more time and then I'll let you try a couple on your own. Alright, so here we go. Get the vertex. So since this is vertex form, I do the opposite of that, so -2, with whatever this is, so -5. Alright, so let's plot our points. So we're going to -2, -5.
Oh, here you go, G.
Yep. So, right there. Okay. Now, let's draw our axis of symmetry. Like so. Alright, now, let's figure out how this line moves. Okay. A times 1, 3, 5, and 7. Right 1, right 1, right 1, right 1. Okay, now my A value this time is positive 2. So 2. 2 times 1, we're going up 2, up 6, up 10, up 14. Okay, so here we go. So, right 1 up 2 goes right there. Right 1 up 6. 1, 2, 3, 4, 5, 6. Right 1 up 10 is not going to happen for us. So let's reflect. So 1 space, 1 space. One, 2. So 1, 2. Okay. Now let's connect the dots to the best of your ability. Alright, there's our graph. Alright, so let's fill in the rest of this. Axis of symmetry is the x-coordinate of the vertex. So, oops. So x equals negative 2. Shift, we went left 2, down 5. Reflection, since the graph is going up, there's none. Opening up. Minimum or maximum, again, the vertex is the lowest point of my graph, so it's a minimum. The minimum value is the y-coordinate of the vertex, so y equals negative 5. Shrink, stretch, or neither. Okay, so we're going to compare the absolute value of a to 1. Absolute value of 2 to 1. So 2 compared to 1 is still greater than, so this is a stretch. Domains, there's no restrictions on my x's, no gaps, so all reals. Now the range, my graph values, my y values are all larger than negative 5. So y greater than or equal to negative 5. And there it is. Alright, so I'm going to let you try this one on your own. We'll see how you do. Okay, I'll come back in about a minute. Just leave the tape running, and I will come back and see how you did. Alright, so let's come back and talk about this. So again, I got vertex form, but notice something's wrong. I'm missing the value that should be here, the k value. So since I'm just adding, we say it's plus 0. So that was a little tricky. Now, so here we go. So let's start off. Let's get our coordinate. Alright, so we're going to do the opposite of this guy. So negative 1 and 0, because I take that. Alright, so we're going to graph our point. So negative 1, 0 is right there. Alrighty, my axis of symmetry. I can do a better job than that. That looks awful. Try that again. Alright, so now we have our axis of symmetry, we have our vertex. So now, hey. So now from here, let's get our movement. We're going to keep doing that. Alright, so we're going to go A times our 1, 3, 5, 7, right 1, right 1, right 1, right 1. So again, now, my A value in this case is right there, so it is negative 1. Alright, so 1 times negative 1 is negative 1, so we're going to go down 1, down 3, down 5, down 7. Alright, so here we go. So coming in. Keep doing that. Alright, so here we go, folks. So right 1, down 1. Right 1, down 3. Right 1, down 5. 1, 2, 3, 4, 5. Okay. Now we reflect. So one space, one space. Okay. 1, 2, so 1, 2. Yep. Let's make that look a little better. Okay. 1, 2, 3, so 1, 2, 3. Like so. And we connect the dots. Like so. Alright, so now let's fill in the rest of this fun stuff. Okay. Axis of symmetry, x equals -1. Shift, we only went left 1. Reflection, since the graph is going down, it's going to be over x-axis. Okay. My vertex, since the highest point of my graph is a max, the value is my y-coordinate, so y equals 0. Now again, my shrink, stretch, or none, absolute value of a when compared to 1. Now again, since my a value was -1, absolute value of -1 is 1 when compared to 1 is equals, so it's none. Domain, there are no restrictions, there's no gaps, so funky R, all real numbers. My range values, now notice my y's don't go above 0, so y's have to be less than or equal to 0. Alright folks, try this next one. I'll give you about a minute to work on it, and then we'll come back and talk about it. Alright folks, here we go. So let's start talking about this one. Again, notice I am in vertex form. So I'm going to take the opposite of this guy, so -3. And we're just going to grab this guy, so -2. So there's my vertex. So let's zoom in and let's make our vertex at -3, -2. Okay. So -3, -2. Right there. Now again, remember we also have to do our axis of symmetry. Like so. Alright. So now we have to figure out how this line moves. Okay. So we're going to do our 1, 3, 5, 7. A times 1, 3, 5, 7. So right 1, right 1, right 1, right 1. Okay, now my a value in this case is going to be 1/2. So this is going to be a little interesting, but I think we can handle it. Okay, so here we go. 1/2 times 1 is positive 1/2, so we're going to go up 1/2. 1/2 times 3 is 3/2, so up 3/2, which is really 1 1/2. 5/2, 1/2 times 5 is up 5/2, which is really 2 1/2. And 1/2 times 7, so up 7/2, which is up 3 1/2. Alright, so there's our pieces. Okay, so let's move in and start graphing. So here we go. So, I'm going to go right one, up a half. So right about there. Right one, up 1.5. So 1.5 would be right there. Right one, up 2.5. 1, 2.5. Right about there. Right one, up 3.5. 1, 2, 3.5. Oops, be right about there-ish. Okay. Now, we'll reflect this over the axis of symmetry. So, 1 space, so 1 space. Okay. 1, 2, so 1, 2. 1, 2, 3, so 1, 2, 3. 1, 2, 3, 4, so 1, 2, 3, 4. Like so. Alright, so now let's connect our dots. Alright, so there's our parabola. Now, let's fill in the rest of the stuff so we know what we're doing here. Okay, axis of symmetry, x, whoops, turn on the pen. X equals -3. Alright. Shift, we went left 3, then we went down 2. Reflection, since we went up, is none. Opening up. Again, my vertex is the lowest point I have, so it's a minimum. The minimum value is this, so y equals -2. Alright, for shrink, stretch, or neither, take our a value, compare it to 1. Now a in this instance was 1/2. So 1/2 compared to 1, get rid of that, that looks awful. So 1/2 compared to 1 is less than. So since it's less than, this is a shrink. Alright, domains. There's no restrictions or no holes in my graph, so all real numbers. The y's, now notice all my y values are all going to be bigger than 2. So y's are going to be greater than or equal to 2. And there's that one. Alright, so I'll let you try this one on your own. Let's see how you do. I'll give you about a minute to work on it, and then we'll talk. Alright, let's talk about this one. First things first, I notice I'm in vertex form. So, opposite of that, that gives me my vertex. Alright, so let's zoom in and let's graph our coordinate at 1, 3.
Roger Sampson, please come to the
There
main
we go.
office. Roger Sampson to the main office.
Alright, now, from here, let's graph our axis of symmetry. Alright. Zoom out, and now let's figure out how this line moves. Okay, so we're going to do A, oops, turn on the pen. A times the 1, 3, 5, 7. So right 1, right 1, right 1, right 1. Now in this case, my a value this time is -3/2, so we got to be careful. Okay, so I'm going to scooch out a little bit more to give myself some more room to work. Alright, so here we go. -3/2 times 1 is -3/2, so we're going to go, turn the pen back on, we're going to go down 3/2 or down 1.5. Let me make that look like a D and not something else. Okay. This next one, we're going to do -3/2 times 3, which is -9/2. So that says we're going to go down 4.5. Okay. -3 times 5 is -15/2. So we're going to go down 7.5. And then this is going to be -21/2, which is -10.5. So we're going to go down. Let me fix that. Try doing something else. We're going to go down 10.5. Alright, so here we go. Let's do this up. So let's zoom in. Okay, from here. So we're going to go right 1, down 1.5. So 1.5 right about here. Oh. Make that a little better. Okay. Now we're going to go right 1 again. We're going to go down 4.5. 1, 2, 3, 4.5. And we're going to go right 1 again, down 7.5. 1, 2, 3, 4, 5, 6, 7.5. So a smidgen over. Maybe about there-ish. Okay. Now let's reflect. So one space, 1, 2. So 1, 2. Okay, then we have this one. 1, 2, 3. So 1, 2, 3. Okay, so now let's do this up. Alright, so there's your graph. Okay, so now let's fill in the rest of this information. Okay, axis symmetry, x equals 1. Shift, you went to the right 1, up 3. Reflection, now since my graph goes down, it's over x-axis. Okay, minimum or maximum, the vertex is the highest point of my graph, so it is a max. Max value, y equals 3. Now shrink, stretch, or none, we take our a value, which was -3/2, compare it to 1. 1. Alright, let's try that again. 1. So again, 3/2 compared to 1 is greater than, so this is a stretch. My domains, no restrictions on my x's, so real numbers, all reals. And the range, now again, notice my y's don't go higher than 3, so therefore y is going to be less than or equal to 3. Alright, here's another one you can try. I'll give you about a minute, and then we'll come back and talk about this one. Alright. Alright, I'm going to start doing this problem. Again, if you're not done, just pause the video. Alright, so again, here we go. Vertex opposite of that with this. So 8. Axis, oops, we got to plot our points. I'm getting ahead of myself here. Alright, so here we go. We're going to plot the coordinate 1, negative 8, or negative 1, 8. Hey! Now try it. Alright, we're going to graph negative 1, 8. Yeah, that one's look awful. Make it a little better. That's pretty good. Alright, now let's do our axis of symmetry. Okay, now we got to figure out how this thing moves. So again, my A value is negative 4. So negative 4 times 1, 3, 5, 7. So negative 1, so right 1, right 1, right 1, right 1. Here we go. So negative 4 times 1 is negative 4. So down 4, down 12, down 20, down 28. Okay, so by the look of this, we're only going to be able to do 1, maybe 2 points. So let's find out. So we're doing, let's go back. Oops, there we go. Alright, so here we go. So right 1, down 4. 1, 2, 3, 4. Right 1, down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whoops, 11, 12. Should be there. Okay, now we'll reflect that. So 1 space, 1 space. And then we go 1, 2, so 1, 2. Okay, now let's graph this thing. Okay. Alright, now here we go. Let's do all the rest of this fun stuff here. Okay, axis of symmetry. Whoops, I always forget to turn the pen on. X equals negative 1. Okay, shift. We went left 1, up 8. Reflection, since this goes down, is over x-axis. And it opens down. Minimum or maximum, again, our vertex is the highest point in the graph, so maximum. The maximum value, y will equal 8. Okay. Now, shrink, stretch, or neither, so the absolute value of negative 4 when compared to 1. Absolute value of negative 4 is 4, when compared to 1 is greater than, so this is a stretch. Domain is all reals, because again, there's no gaps in the graph, there's nowhere that the x's don't go. But the y's, again, notice my graph does not go above 8, so y's have to be less than or equal to 8. Alright, one more, and then we'll call it a day. So this video's been pretty long. Alright, so give this one a shot. We'll see how you do, and then I'll come back, we'll talk about it, and that'll be it. Alright, here we go, folks. Again, vertex form. So opposite of that, negative 3. With that, negative 3. Alright, so here we go. Let's graph that thing up and see what we do. So negative 3 by negative 3. Okay, negative 3, negative 3. Right there. All right, let's do our axis of symmetry. Okay. Now we got to figure out how this is going to go. So here we go. We do our a value times the 1, 3, 5, 7. So right 1, right 1, right 1, right 1. Now our a value in this case is going to be 2. So 2 times 1 is 2, so we're going to go up 2, up 6, up 10, up 14. All right, so let's zoom in and take care of these things. Okay, so here we go. Right 1, up 2. Right 1, up 6. 1, 2, 3, 4, 5. Oops, did it again. Right 1 up 10 is going to go off the graph, so obviously we can't do those. So now, reflect, so 1 space, 1 space. Oops, that was terrible. That's better. Next one, 1, 2, so 1, 2. Okay, now let's plot our point, or connect our dots. Yeah. There we go. All right, now let's answer all our questions. Okay, so here we go. Axis symmetry, x equals -3. Shift, we went left 3, down 3. Reflection, since it goes up, is none. Open or close, or up or down, it's up. Again, my vertex is the lowest point in the graph, so it's a minimum. Minimum value, y equals -3. Okay, vertical shrink, stretch, or neither. We could take a and compare it to 1. So again, my a value in this case was 2. So absolute value of 2 compared to 1. So 2 compared to 1 is greater than. So this will be a stretch. Domains, are there any restrictions or gaps? The answer is no. So all those. Range, now again notice my y values do not go below -3, so y has got to be greater than or equal to -3. So finally we're at the end of this video, and again I apologize for this being so long, but there was a lot of information to go through. So hope to see you next time. Hope you learned a lot. And again, if you need to, replay the video or pieces of it that you didn't get, so then that way we'll have everything down.